Okay, so 6-4 notes, rectangles. So when you look up here, one thing you want to note is all the characteristics of a parallelogram are true of a rectangle. What makes a rectangle different are these two things right here. All four angles are right angles, and the diagonals are congruent in a rectangle. So it is a parallelogram, but it's unique in that it has four right angles and the diagonals are congruent, and that's what makes it a rectangle. So very similar in what we did in the previous lesson, but now we're focused specifically just on rectangles. So again, always use these examples as references. Make sure you go to those. Okay, so it's telling me in this picture that this is a rectangle. So again, I'm not going to do all these problems, but I'm going to do some of them. Now, what I would suggest to you is use the picture, but always write in pencil on the picture so then that next time you can erase it and then label it with the next one. So for example, I'm going to do number 1. It says AE is 36, and then CE, so there's AE, and then CE right here is 2x minus 4. Now what do I know? I know because it is a parallelogram, diagonals bisect each other, which means that those two things are equal. So I know 36 equals 2x minus 4, so I add 4. It's 40 is 2x divided by 2, and that's going to give me x is 20. So that would be problem number 1. Then I would take my eraser on my pencil, and I would get rid of all this stuff, and then I would label for the next one. So I'm going to go down to problem number 3. So in problem number 3, it says BC is 24. So BC is 24, and AD is 5y minus 1. Now, what are those? Those are opposite sides. So what do we know about opposite sides? They're congruent. So 24 equals 5y minus 1. Add 1, get 25 is 5y divided by 5, and that would give us y is 5. Okay, so again, after I solve that one, I would take my eraser, put it on all that, and get rid of it, and then label the next one. So I'm going to do each of the odd ones here. So I'm going to slide to number 5 here. Angle AED, so it's real important here. AED, trace it, AED, that's right here. So this is 12x. And BEC, BEC is right here, which is 10x plus 20. Oops, plus 20. Okay. So what kind of angles are those? Those are vertical. They're back to back. So what I do, I set them equal. So 12x equals 10x plus 20. So sometimes things are related not because they're rectangles or parallelograms or anything. It's just because of previous relationships we've learned, such as vertical angles. So we subtract 10x, gives us 2x is 20, divide by 2, x is 10. Now, here it says find AED. So what I have to do is I got to take 10, plug it back in right here. So if I do 12 times 10, that is 120. So the measure of angle AED is 120 degrees. All right, let's get rid of all that. Number 7, DBC, so we're still doing angles here. DBC, angle DBC, so that's right here. DBC, that's that little one there, so that's 10x. And then angle ACB, angle ACB, right here, angle ACB. That angle is 4x squared minus 6. Oh man, this one's going to be ugly. 4x squared minus 6. So what do we have here? Since this is a rectangle, so I'm gonna show you something new here. Since this is a rectangle, and we know all the angles are 90 degrees, so I'm going to draw this picture a little bit bigger. So we got this diagonal here, and that's 10x. We got this diagonal here, and that's 4x squared minus 6. Because they are 90 degrees, and when you draw the diagonals, what happens is this creates an isosceles triangle. In other words, those two angles have to be equal here. So one thing to note, I'm going to go back up here in this picture. That is an isosceles triangle. That's an isosceles triangle. And those two triangles are congruent to each other. Same way on the two on the side. So if I take this triangle on the side, this triangle side, they're isosceles and they're congruent. So the relationship you get here is 10x, equals 4x squared minus 6. Now, we haven't done very many squared problems, but I am going to go ahead and work this one out for you real quickly just so we can have a little bit of review of some algebra. So I'm going to move this over so I got some room because I'm going to need some room with the squared. So right here, excuse me, I'm going to move the 10x over. So to do that, I subtract 10x. Now, remember, you cannot subtract these two terms because one's squared, the other one's not. So I end up getting 0 equals 4x squared minus 10x minus 6. Okay, then what you want to do is you want to try to factor. Okay, so what I know 2 will go into all those. So I take a 2 out. So it's 2x squared minus 5x minus 3. Then I'm going to factor all of this. So that try to factor this trinomial. Now you may not remember, but this is where you do kind of the reverse FOIL thing. So this is going to be 2x, and that'll be minus 1, and then this will be plus 1. No. Sorry, minus 3. There we go. And then this is plus 1, and then that's x. Because what this gives me is negative 6x. That gives me positive 1x, which would give me together a negative 5x. So I have 2x plus 1, and that has to equal 0, and x minus 3 equals 0. So I had 3. So that gives me x is 3. Subtract 1. 2x is negative 1. Divide by 2. So x is negative 1/2. Now, you get two answers because this was a squared problem. Now, what it wants us to do is find angle ACB. So let me come back over here. Here is ACB. So the first one I'm going to plug in is 3. So I do 4 times 3 squared minus 6. If I do that, that's 9 times 4 is 36. Minus 6 is 30. So that works. I try the negative 1/2. 4 times negative 1/2 squared minus 6. And that's going to be 4 times 1/4 minus 6, which is 1 minus 6, and that's a negative 5. That does not work. You can't have a negative angle. So in this case, the only one that works was the x is 3. All right, let's go to the second page. So here we're proving that it is a parallel or a rectangle. Sorry. And it says prove using the distance formula. Now, remember we did this with doing parallelograms, but the difference is you want to prove that it's a rectangle. Okay, so in order to prove that it's a rectangle, you've got to do distinctive aspects of the rectangle. So the only thing that distinguishes it is that that it forms right angles, has 4 right angles, and that the diagonals are congruent to each other. So I'm only going to do one of these because it's pretty involved, but I'm going to show you how to do it. And again, I think slope is easier, but I'm going to do distance formula for this one, and then I'll show you real quick how we could do it using slope. Okay, so I'm going to draw a picture, and we'll label it ABCD. And I'm going to put the coordinates. Remember, you can do this on your little board. All right, so the first thing you want to do is you want to find that it's a parallelogram, which means opposite sides are congruent. So you got to do distance formula for opposite sides. Now the good thing is here, these are both 1, so all I have to do is look at the change in x. Negative 3 to 3 is 6, so that means this side's 6. These are both 3. Negative 3 to 3 is 6, so that's 6. So those two are the same. I look at the side AB. That's -3, that's -3. So I just look from 1 to 3, I went up 2, so that's a side 2. Now, my picture doesn't match my information, but that's okay. 3, 3, 1 to 3 is 2. So it is definitely a parallelogram. Now I have to do the diagonals. So I'm going to get rid of all that stuff that I just wrote. And now what I'm going to do is find the distance of the diagonals. Okay, so the diagonals are going to be dB. So now I have to find the distance from D to B. So I'm going to come down here. So dB, so I use that square root formula. X2 minus x1 squared plus y2 minus y1 squared. So we do change. So that's 6. 6 squared is 36. 1 minus 3 is -2. -2 squared is 4. That's square root of 40. Then I have to find this diagonal, A to C. So I'm going to work it out over here. Square root x2 minus x1 squared plus y2 minus y1 squared. So that's -6 squared, which is 36, -2 squared, which is 4, and that's square root of 40. Those are the same distance. So it was a parallelogram, but now that I know diagonals are congruent, then I know it's a rectangle. Now I did say I wanted to show you how to do with the slope too. Here's the good thing about slope. Remember, it makes right angles. So if it makes right angles, then they have to be perpendicular. So let me show you how to do that. So remember, slope is change in y, 1 to 3, that's a change of 2. Change in x, there is no change. Okay, so 2 over 0. Now I'm going to do side BC. Change in y, which is 0. Change in x is a plus 6. Now, these are perpendicular because this is undefined, and this would be a slope of 0. In other words, this is a vertical line, even though my picture shows it horizontally, and this is a horizontal line. So vertical line and horizontal lines are perpendicular to each other. Again, kind of a tough lesson, a lot of stuff you got to know,